I think, let's start. Okay, we have 4 children now, right? Hello. Can you hear me?
Yes, sir. Good morning, sir. Good evening, sir.
Yes, good evening. Ram Prasad, Jagan Ram, Rakshan, Pavan. So you're all from 11th or 12th? Each one of you?
11th.
Ram Prasad, you are 11th. What about the rest? Jagan Ram? 11th. Rakshan, Pavan?
Sir, 10th.
Rakshan is from 10th. Okay. Pavan?
Robert.
Pavan, what did you say? I didn't hear.
Sir,
Sorry?
11th doctor.
சரி ஓகே குட் ஸோ இன்னைக்கு 11th போர்ஷன் தான் நம்ம கவர் பண்ண போகிறோம் ஸோ ஃப்ரம் த சாப்டர் ஃபர்ஸ்ட் சாப்டர்லாம் நம்ம இருக்கோம் ஸோ வி ஆல்ரெடி கவர்டு செட்ஸ் அண்ட் ரிலேஷன்ஸ் ஸோ இன்னைக்கு வந்து ஃபங்க்ஷன்ஸ் பற்றி நம்ம பார்க்க போகிறோம் ஓகே ஸோ ஆல் ஆஃப் யூ ஆர் தமிழ் ரைட் ஃப்ரம் தமிழ் கேன் ஸ்பீக் தமிழ் இல்லையா எல்லாரும் இஸ் எனிபடி ஐ கேன் ஸ்பீக் இங்கிலீஷ் ஆல்சோ எவ்ரிபடி கம்ஃபர்டபுள் வித் தமிழ் ஆர் prefer English? Right. So
Comfortable with Tamil, sir.
very good, Rakshan. Okay, good. Fine. So I'll go with mostly I'll go with mix of English and Tamil as I normally do. Okay. So உங்களுக்கு எது comfortable அதை நீங்க சொன்னீங்கன்னா if something you are not following I can explain and say the other language. சரி. So we will go to the board now. Okay, I have a board where we can work out the problems. Okay. Meanwhile, right. So you can see this. Functions. Okay. Can you see my screen?
Yes, sir.
Okay. Fine. Okay. So this gives an overview. I am assuming that the functions has been already, this chapter has been covered in your school. Okay. So this is an opportunity for you to clarify all your doubts. I'm going to revise the important concepts and go through some problems so that, your understanding is more complete. And if you have any doubts on whatever you have learned in your school, you can please ask. Okay, so that is why this session is mostly for clarifying your doubts. Okay, otherwise, you have plenty of materials that you can look at, but suppose you don't follow something, you don't want to understand, why this is, given in this way, why is it like this? Okay, so this is an opportunity for you. Okay, so function, is a special kind of relation, as we saw about relation, which is a mapping from one set to another, based on a condition. Okay, and function is a subset of relation. Okay, which satisfies a condition. What is that condition? Okay, the condition is that for every element of X of set A, there is only one and only one image of Y in set B. Okay, so that is very important. So f of X has to be unique. Set that cannot be mapped to multiple elements in the Y set. Okay, so that is condition number one. And second is every element of X. Note that word, every element. So everything in the domain. Okay, so set A is called the domain. When there's a mapping from A to B, then Set A is called domain and set B is called codomain. Okay. Now, every element of the domain, that is set A, should be included in the function, and every element of A should be mapped to only one value in the other set. Okay, so that is a special type of relation. Okay. So we saw the definition of domain. Domain is your set A, and codomain is a set B, and the range of the function is a set of images. So what are all the elements that are mapped, right, in the set B? Maybe we can draw something. You set A and set B. Set A has got certain elements. Set B has got certain elements. Okay, so the condition for function is that every element in A should have a unique mapping in B. So, for example, this can be mapped to 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 this, and this can. Suppose if it is only these are the mappings, then it is still not a function because one element is not covered. So, if everything is mapped, okay, so then it becomes a function. Okay. So if the function now, everything in A is covered, and every element in A has got unique image in B. Okay, so this is all the condition for a function. Okay. So that is the definition of a function. Okay. Yeah, you see this. Okay. Okay. So the representation of a function can be in tabular or graphical or analytical. Graphical means like I have drawn, here. Okay. Other one is called listing. Listing means, for each element, suppose this is 1 and this value is 2, this value is 2, and this value is 3. So the 1 is mapped to 2, okay, and then 2 is mapped to 3, and so on. List all the mappings in this way. So this is one way of representing. So one way is, the arrow diagrams. The second way is your listing, and the third way is if there is a relation, if there is a condition based on it, this mapping is done. So you write f of A to B where this is the condition. For example, element, this is B. These elements are, let's say, y equal to 2x. So if you say y, this is a condition, and this, so 1 will be mapped to 2 and 2 will be mapped to 4 in that case. Okay. So this is the third way of representing a function. So this is the representation of function. Okay. Okay, a real function, Abdina, that means it's a set of real numbers on one of its subsets or one of its subsets, both as its domain and its range. So domain and range all should be only real values, then it is called a real function. There are some common functions like identity function. Identity function means x is equal to x. So that is called, y equal to x. So x is mapped to itself. So that is your identity function. Constant function is x is always mapped to a constant. So one value only. Everything in the A set is mapped to only one value on the Y set. And polynomial function. Polynomial means it's a polynomial expression. Okay. Which is only, it is like A into x to the power of n plus B into x to the power of n minus 1. In that kind of function is called a polynomial function. Like a linear function, quadratic function. So they're all polynomial functions. So rational function. Rational function means, that it can be represented. Numerator, it's a fraction where numerator and denominator both are polynomial functions. modulus function. Okay, modulus function means if it's just a positive value of that the set in B, that the modulus of some value. I'll write it down. It's got some special property. So if you say modulus of a positive value, it is the same value. Whereas a modulus of a negative value will be its corresponding positive value. That means what we how we define is f of x equal to x when x is greater than or equal to 0, when x is positive, and f of x equal to minus x when x less than 0. So this is what is your modulus function. So that means always it is going to be positive. And signum function is the sign. Okay, so it's basically modulus of the function value divided by the modulus will give you the sign. So whether it is a positive function or a negative function, so that's called signum function. Greatest integer or floor function. So if it is a real number in the real axis, you take the greatest integer below the value of x. Okay, so that is called the greatest integer. Smallest integer or CIL means what is the smallest integer above the value of x. And something like we represent the floor function in this way, and the CIL function in this way. So this is the greatest integer or floor function is the first one. So that, see, let's suppose there is a fractional value, so let us say decimal 2.3, then the floor function is going to be the greatest integer less than this 2.3. So that means it is 2, right? Integer is 2 here. Similarly, same if you take 2.3, the CIL function means what is the greatest integer but less than this 2.3. Okay, so that will be the next higher integer. Okay, that is the smallest integer. Sorry, this is smallest integer, but it should be greater than this x. So that means this will be 3. So this is the greatest integer, which is less than this value. This is the lowest integer, but greater than this value. That means it is, you can say that is a rounding off to the next number, and this is rounding off to the number below in the number scale. These are some other type of functions, like linear means it's a single degree function. Non-linear, quadratic. Logarithmic means it's of the form y equal to logarithm of a into logarithm of x. Y equal to a logarithm of x to the base of b. In the form of logarithm, that is your logarithmic function. Exponential means similarly, y equal to a into b to the power of x. So x appears in the exponent. So that is your exponential function. Reciprocal means it is given a function. The reciprocal of that function is 1 by that function. So that is the reciprocal. Odd, even. Do somebody know what is odd and even function? What is odd function? A function is an odd function if f of minus x, calculate f of minus x is equal to minus f of x. If this condition is satisfied, this is called odd function. And an even function is same, f of minus x is equal to f of x. And for example, if you take f of x equal to x square, this is odd or even function?
Even.
Because f of minus x is equal to minus x whole square, which is also x square. So therefore, it is even function. Whereas f of x equal to x, okay, so that will be a odd function, because in that case, f of minus x will be minus of fx. Okay, so those are all the different types of functions, and then we have some properties of functions. So we call f plus g of x is f of x plus g of x. F minus g of x is f of x minus g of x. F into g of x is f of x into g of x. So f divided by g of x is f of x divided by g of x, and kf of x is k times f of x. So these are some algebra associated with function, and a couple of important properties is one-to-one and on-to. Okay, one-to-one and on-to. So if you take a function that we drew before, the function will be one-to-one. In this case, you can see that, so this can be mapped to the same value also, right? Instead of this, I could have mapped this to this value also. If I did that, then multiple values in the A set gets mapped to same value in B set. Okay, so that is called many to one. So many values here map to one value on the B side. So something that is not many to one is one to one. Okay, so one to one illa abdina adu many to one இருக்கும். So many to one abdina many values in the A set are mapped to one value in B. One to one abdina the B la எதுக்குமே multiple mapping வரக்கூடாது. So B everything is in A is mapped to a unique value in B. So that is one to one. And then your onto or surjective function abdina, everything in the codomain should be included, covered in the function. So if you're thinking some values like this, okay, it is not covered. Okay, in this set, everything that is in this set should be covered in the function. So should have a pre-image. So abdi irukadna onto abdin per. If something is left out, then it is not a onto function. Because if you try to draw a function from B to A, it is not possible, because for something there is no corresponding pre-image. So அந்த மாதிரி இருந்துச்சுன்னா நம்ம A to B B to A திருப்பி வர முடியாது. So that is called inverting a function. So inverse will not be possible either if it is many to one. If many to one இருக்குன்னு வச்சுங்களேன், இப்போ now since there are two values mapped to this, இங்கிருந்து suppose B value is given, what is the corresponding A value? ரெண்டு இருக்கு, we don't know which one. So therefore we cannot determine A given B. Similarly, there is no pre-image defined for something if it's not onto. So basically one-to-one is any value in A is mapped to a unique value in B, and that is just a function, but no two values in B are mapped from the same A. So like I explained in the diagram, and on to abdina everything in B set should be covered. Okay, with that, if both the conditions one-to-one and onto are satisfied, it is called bijective function. Okay, one is one-to-one, it should be one-to-one and it should be onto, then it is called bijective function. And the condition appada number we can find out a inverse. What this means is, given the value of B, okay, can we determine the value of A? So that is if we can do that, then it is called a inverse function. Okay, the function is invertible. For a function to be invertible, it should be one-to-one and onto. Okay. So then we have this composition functions. Composition of functions is if there is a mapping from A to B and then also from B to A, then we can map from corresponding map from A to C. Okay. So for example, So there is a set A here, there is a set B here, there is a set C here. Okay. So here there are some values. Let us say 1, 2. I'm writing some numbers 3, 4. Here there are some values 5, 6, 7. Here there are some values 8, 9, 10. Okay. So 1 is mapped to this, 2 is mapped to this. Let us say 3 is also mapped to this, and 4 is mapped to this. And this 5 is mapped to 9, 6 is mapped to 8. Then if you say this is, let us say, f, this function, this mapping is f, and if this is g, okay, then g of f of x, g of f of x abdina, first we have to calculate f of x, and then for whatever value you are getting as f of x, what is the corresponding mapping, g mapping. For example, if you take a1, if you take 1, it is mapped to 5. So f of 1 is 5, and g of 5 in what is 5 is mapped to 9. G of 5 is 9. So f of g of 1, sorry, g of f of 1 equal to 9, because f of 1 is 5 and g of 5 is 9. So this we write it in this way: g of f of 1, or g o f of 1. Similarly, you can calculate for 2. 2 is mapped to 6 and 6 is mapped to 8. Therefore, g of f of 2 is equal to 8. Like that. Okay. Okay. So I think those are the concepts. So is there anything that you did not understand from your book, whatever was taught or whatever I told now? Edachu purilana, please ask me now. Any doubt? Okay. Now let's go to some problems. Okay. So let's go to some problems. Okay. Now suppose that there are 120 students studying in 4 sections of 11th standard in a school. Okay, so let A denote the set of students and B denote the set of sections. Define a relation from A to B as X is related to Y if the student X belongs to section Y. Okay, so this is the relation. So look at it. If you want, you can draw it yourself. Okay, draw a diagram representing this relation. And tell me, is this relation a function? Is this relation a function? Can anybody tell? Okay. Now, these are all the students. Okay. Let us say Ram, Krishna, Janaki, like that. Radha. Some 4 students are there. Now, there may be many students. There are, how many students are there? 120 students are there. So I'm not listing all of them. The remaining students, I'm just saying S5, S6, S7, to S120. And here is a set of sections. So how many sections are there? 4 sections are there. Let us say the sections are A, B, C, D, right? Section A, section B, section C, section D. Now, the relation is, if Ram is in section A, so then he is mapped to A. So Krishna is in section C, let us say C is mapped to C. Janaki is in section A, probably. So she is mapped to A. Radha is probably in D, mapped to D. So another student can be in some other B section. It can also be in B section, and so on. So that's why we are going to map for each and every student what section he or she belongs to. So if you do that, is this relation a function? So what are the two conditions for being a function? I told. Condition 1, this is called domain. Okay, and this is called codomain.
Sir, 1-to-1 and on-to.
1-to-1 and on-to. No, I just asked, is this a function? Is this a? What are the conditions for being a function? So what you are saying is there are two types of functions, 1-to-1 and on-to. Okay. But I'm asking a different question. For something to be a function, okay, what is the condition? Two conditions are there. What are the two conditions? All elements in the domain should be included in the relation. That means everybody should be assigned to one of the sections. Is that true? In a class, in a school situation like this, is this true or false? You tell me, Pavan. Is it true or false? All elements in the domain are included or not included?
True, sir.
They're included because everybody is given a section, right? Everybody will be either in A, B, or C, or D. So everybody will be mapped to one section or other. So all elements in the domain are mapped. Yes. That is condition number 1. What is your condition number 2? Everybody should be mapped to only one element in the set B. Every element in set A should be mapped to only one element in set B. That means Ram is mapped to only A section. He cannot be mapped to A and B. Okay, obviously he will not be because Ram will be in only one section. Either will be in A or B, but not in both, right? So similarly, everybody will be mapped to only one section. That is the second condition. Every element in the domain should be mapped to only one element in the codomain. So every element is mapped to only one element in the codomain. That means if you say f of Krishna is what, I should be able to say C. I should not get confused. If Krishna, I don't know whether it is A or B or he could be mapped to both, and it's not like that. When we say what section Krishna belongs, it's only one C. So that means that is true for everybody. Any S120, 120 student, he will be mapped to only one section. So given a value in the domain, there is only a unique value in the codomain. So that is the second condition. Please remember, these two conditions should be satisfied for something to be called as function. Okay. In this case, this is also satisfied. That is the reason why we can say this mapping is a function, right? So is it a function or not? Do you agree? Okay. Next, you tell me what can you say about the inverse relation? is it invertible or not invertible? For that only, we have to check whether it is 1-to-1 onto. So now tell me, with this relation, is it 1-to-1? It's 1-to-1 or many to one? So you can see, so many students will be mapped to one section because there are 120 elements here and only 4 elements here, and 120 all of them should be mapped to these 4. That means many elements here should be mapped to a single element here, right? So obviously in one section there will be many students, right? So that means, so this is 1-to-1 or not 1-to-1? Not 1-to-1, right? Is it onto? Is it onto or not? It is onto because every section is covered. Every section will have at least one student. Okay, assuming that every section will have at least one student, it is onto, right? So it is an onto function, but not 1-to-1. For a function to be invertible, it has to be both 1-to-1 and onto. Here, this is not 1-to-1, but onto. Therefore, since it is not 1-to-1, this is invertible is no. We can also say that if you say section A, can you say which student? There can be many students. So you cannot determine, if you just say section A, which student you cannot determine, right? Because there are many students. So unless there is a 1-to-1 mapping, we cannot determine student given the section. Given a student, we can determine the section, but not the other way around. That's why. Okay. So that means basically the answer to this question is this relation a function? Yes. Is this relation a function? It is a function. What can you say about the inverse relation? It is not an invertible function because it is not 1-to-1. It is a many-to-one function. That means it is not invertible. Okay. Okay. Suppose there is another a function like a relation like xy equal to -2. That's a relation. Okay. It's a function for a suitable domain. Find the domain and the range of this function. So this is a kind of problem that you will normally encounter. Find out the domain, find out the range, find out the codomain. Those kind of questions will be asked. So xy equal to -2 is a relation. Okay. So that if you want to write it in the form of function, xy equal to -2. If you want to write it in terms of function, we can write it as y equal to -2 divided by x. Y equal to -2 divided by x. We can write like that. Okay. Because xy equal to -2 means y equal to -2 by x. So this is a function because for every value of x, there is going to be a unique value of y, which is given by -2 divided by that x. Okay. So this is your function, y equal to -2 by x. Now, what is the question now? What is the range of the function? What is the range of the function? So range of the function is what are the values that y can take? What are the values that y can take? Let us say x can take any value from -infinity to +infinity, the real function. Let us say it is a real function. X can take any real value. Then what are the values that y can take? Range of values. Find the domain and range of the function. That is the question. Okay. So what is the domain? First of all, let us say find out the domain. Domain means what are the values that x can take. Let us say first. Let us do that. Domain. What are the values that x can take? That means y equal to minus 2 by x. When is it defined? For what values of x is it defined? Is it defined for all real values? No, because when x equal to 0, then this becomes undefined. We know that something divided by 0 is undefined. That means this is not defined when x equal to 0. That means what are the values that x can take? Means any real value other than 0. This we write as r minus 0. Okay. So all are real values minus 0. Okay. So that is your domain. So what is your next question is range. So what values can y take now? So what are the values that y can take? Think about it and tell me. It is, any real value minus 2 divided by any real value. That means minus 2 divided by whatever value you put, it can take any other real value, but it will never become 0 because minus 2 by x, it can never become 0, right? For any, it is not defined when x is 0. At the same time, it is also not become 0. Whatever big value of x you keep on putting, it will be a small, y will be a very small value, okay? But never it will become 0, okay? So that means same. So this is also all real values other than 0. That is r minus 0. Okay, so this is the range and this is your domain also. It should be written in this way, r minus 0. Okay. So did you all follow?
Yes, sir.
Yes, sir.
Fine. So let's move on to the next problem. Okay. The function, please read this. For exchanging American dollars for Singapore dollar on a given day is f of x equal to 1.23x. Okay. F of x equal to 1.23x. And where x represents the number of American dollars, okay, and y represents the Singapore dollars, okay, exchanging American dollars for Singapore dollars, right? On the same day, the function for exchanging Singapore dollar to Indian rupee is given by g of y equal to 50.50y, where y represents the number of Singapore dollars, okay. So write a function which will give the exchange rate of American dollars in terms of Indian rupees. Think about it. Okay. So this is what is given. Okay. So where your x is equal to Singapore dollar. Okay. Y equal to US dollars, because it is given the mapping between Y and X is to convert Singapore dollars to US dollars. This is a function 1.23x. Wait. Let me check that whether I written right. X represents the number of American dollars and Y represents Singapore dollars, right? So it is given here, right? So I written it wrongly. Sorry. So X represents the number of US dollars. Y represents the number of Singapore dollars. And Z represents rupees, Indian rupees. So this is a relation. So that means Singapore dollars is equal to 1.23 times US dollars and Indian rupee is equal to 50.5 times Singapore dollars. So that's what is the relation. Now, what is Z in terms of X? Z equal to F of Y. But Y equal to 1.23x. Therefore, substitute like 3.5 into 1.23x. So Y equal to 1.23x. So this becomes the relation from Z to X to Z. So that function is Z equal to 50.5 into 1.23. We can multiply. Times X. Okay. So we can multiply then put that. So this is the relation. Z equal to this much into X. Okay, look at this problem. So far, I hope you are following. Any doubt? Please. Now look at this problem. Find the number of all onto functions from the set 1, 2, 3, 4, 5, 6, n, okay, to itself. Okay. So here the domain and codomain both are the same set. 1, 2, 3, 4, all numbers, okay, from 1 to n, natural numbers from 1 to n. So how many onto functions can be created? How many onto functions? Okay, how many onto functions? So there are n elements in this set A and n elements in set B also. Same, it's the same mapping from same set to the same set. So A to A. So there are n elements here and n elements here, and each one should be mapped to only one value here. That is because it is function, and every value it is onto function. Every value is mapped. Since there are n values here, and it is all of them are mapped, then it has to be 1 to 1. Then only it will be everything in the other set will be covered, right? So this has to be 1 to 1 also. It is already given that it is on to. Okay, it is, since it is given that it is onto and there are exactly n elements in both the sets, it has to be 1 to 1 also. Now, if it is 1 to 1, so you take first element. So how many ways can this be mapped? If you take first element, it can be mapped to either 1, it can be mapped to either 2, it can be mapped to either 3, it can be mapped to any of the n values, it can be mapped. So 1 can be mapped to any of the n values. That is, n choices are there. You can either take 1 or 2 or 3 or 4 up to n. Now, once you have mapped 1 to any one value, then 2 can be mapped to how many? Any of the remaining values only, because it is 1 to 1. Because it is 1 to 1. Suppose 1 is mapped to 1, then 2 cannot be mapped to 1, because then it will become many to 1. Okay. So it can be mapped to anything other than this one. That means any of the remaining. That means n minus 1 values. So basically here you have n minus 1 choices. Then once you have mapped 1 and 2, then 3 can be mapped to any of the remaining. Now only since 2 values are already mapped, so remaining there are only n minus 2 choices. So 4, 5 and so on. Finally, the last element can be mapped to, because at that time rest of the elements are all mapped, and the codomain also is going to have only one value, one choice. So basically, this is the number of ways in which you can map. The first one can be mapped in n ways, second in n minus 1, third in n minus 2, and so on. That means totally how many choices you have. First, for mapping, first one you have n of choices, then you have n minus 1 choices. For each of these, n minus 1 second choices, and then next one again, and it is n minus 2, and so on. The total number of functions is n into n minus 1 into n minus 2, so on up to 1. And this we call as n factorial. This we call as n factorial. Okay. So the answer to this problem, I'll go back to the problem. The answer to this problem is n factorial, because of the the reason that we saw, it is 1 to 1 and on 2. Therefore, the first element can be mapped to n values, the second can be mapped to n minus 1, and so on. So the total number of functions will become n factorial. That is 1 into 2 into 3 up to n. Okay. So let's look at problem number 5 now. Let's look at problem number 5. Okay. Problem number 5. So there's a mapping given. F of F is a relation from set 134 to 125. So 134 is a domain, 125 is a codomain. The mapping is given as F is equal to 1 to 1 comma 2, 3 comma 5, 4 comma 1. That means let's write it down. 134 is the domain for F. One two five is a codomain. And for the other set, it is G is mapped from 125 to 13. Okay, so this is what is given. There is a set relation F from 134 to 125, and there is a relation G from 125 to 13. And how are they mapped? The mappings are given. F is 1, 2, 3, 5, 4, 1. 1, 2, 3, 5, 4, 1. 1, 2, 3, 5, and 4, 1. These are they are mapped. And how is the mapping G? Function G is given by 1, 3, 2, 3, 5, 1. 1, 3, 2, 3, 5, 1. Okay. So you are able to represent the entire mapping. Now, what are we supposed to do? We are supposed to calculate G of F. G of F. Or you can write as G of F. Okay. Find G of F. Can you try now? All of you? So we saw, right? Already we saw. What exactly is, G of X. So first you have to calculate F of X for the domain values of X. Domain values of F. Calculate F of X. So that is going to give you the domain values for G. Okay. So from there we have to find out how it is mapped to the codomain of G. Okay. So I'll just write it down. So when X is equal to, so let us say this is your X, this is your Y, this is your Z. Okay. So when X equal to 1, Y equal to 2. X can take values 1, 3, 4. When X is 1, Y is 2. Because the mapping is from 1 to 2 in F. This relation is your F. This relation is your G. 1 is mapped to 2, 3 is mapped to 5, and 4 is mapped to 1. Okay. Now, how is G mapping? 2 is mapped to 3, 5 is mapped to 1, and 1 is mapped to 3. So that means 1 is mapped to 2, and then in terms F is mapping 1 to 2, and G is mapping 2 to 3. Therefore, G of F of 1 is equal to this value, 3. G of F of 3 is 1, because 3 is mapped to 5, and then this 5 is mapped to 1. G of F of 4 is equal to 3. Okay. So you see that this is F is 1 to 1 and on to. Okay. But G is this G of F is not onto, because 3 is mapped to 1 as well as 4. Okay, so this is not onto, not 1 to 1. Okay, it's not 1 to 1. So what is the question? Write down G of F. Okay, that is a question. So G of F is this. Okay, G of F is 1 is mapped to 3. You can put it like G of F 1, 3, 3, 1, 4, 3. Okay. So did you all follow? Right. Now look at this problem number 6. Okay, so this you don't even have to write it down. From whatever we have seen so far, state whether this function just got this mapping 1 to 10, 2 to 10, 3 to 10, 4 to 10. F has got 1, 2, 3, 4, and set A as the domain has got 1, 2, 3, 4, and codomain has got 10. Then is this invertible? Is this invertible? Prasanna, I think you're the only one now. The first one, is it invertible? So invertible அப்படின்னா அது first 1 to 1 on 2 ரெண்டு கண்டிஷன் satisfy பண்ணும். 1 to 1 அது
No, sir.
no, because all the values are mapped to only one value on the other side. So 1 is mapped to 10, 2 is mapped to 10. So that means it's many to 1. So that means it is not inversible. It doesn't have inverse. Okay. Okay. Similarly, look at second problem and tell me whether it is invertible or not. Is it 1 to 1?
No, sir.
Why?
5 is mapped to 4 and 7 is also mapped to 4.
Correct. Therefore, it is not 1 to 1. Okay. Is it on to the second function? Is it on to?
Yes, sir.
Why are you saying that? What is on to? All the elements in set B, okay, should be in the mapping. Irka? 1 irka? Mapping la?
No, sir.
1 is not at all mapped. So that means it is not on to. It is not 1 to 1, it is not on to. Okay. So it is obviously, if any one is not true, then it is not invertible. Okay. So second is also not invertible. Look at third one.
Yes, sir. 1 to 1.
Yes, it is 1 to 1. Is it on to?
Yes, sir.
Okay. It is 1 to 1 and on to. That means it is invertible. Okay.
Okay, sir.
Good. Cherry. Next, we will go to next problem. Okay. There is a function from real to A is given by f of x equal to x square by x square plus 1. It is a surjection. That means it is 1 on 2. Okay. Then find A. Okay. So it is given that it is a mapping from R to A. So that means the X is real. It is all real values are included in X. And A, what is the set of values that A can take? That is, this can take, what are the values that this can take? What is the minimum value this can take? What is the maximum value it can take? So let us put X equal to 0. Then f of X equal to 0 by 0 plus 1. Yeah, so that becomes 0. Okay. So you can see that this numerator is positive, x square. Denominator x square positive plus 1 positive. So it's a positive divided by positive. So then this can only take positive values. It can never become negative. Okay. And it takes, what is the minimum positive value? It is 0. Okay. So that means the minimum it can take is 0. So, okay. And what is the maximum it can take? This x square by x square plus 1. So you keep putting different values for x and see, what values, what all values it can take. And what is the limit, maximum value it can take. Try panni paranga. So let us say put x equal to 2, 3, 4, 5. If you put 2, it becomes 4 by 4 plus 1, 4 by 5. If you put 5, if you put 3, it becomes 3 square, that is 9. 9 by 9 plus 1, that is 9 by 10. It will be 9 by 10. Otherwise, then if you put x equal to 4, it is 16 by 17. So it goes on like that. So what is the maximum value it can take? Can it exceed 1? It cannot exceed 1 because this denominator x square plus 1 is going to be more than the numerator, which is x square. So it is 16 by 17, then 25 by 26. And then if you put x equal to 10, it will be 100 by 101. It goes on increasing, but it will not reach 1. Okay. Or you can put it like this: x square by x square plus 1 dividing by x square, both the numerator and denominator will become 1 by 1 plus 1 by x square. Okay. So if you go on increasing the denominator, the value of x, so this will, at some point in time, when x becomes very big, this will become 0, in which case it will become 1 by 1, which is equal to 1. But it will happen when it is very, very big, but it will never actually reach 1, but it will become very close to 1. Okay. So lower limit equal to 0, upper limit equal to less than 1, not 1. Okay, it can never not reach 1. So how do we write this? The lower limit is 0 and upper limit less than 1.
Square bracket 0, comma, close bracket 1.
Very good. Very good. So the values it can take are from 0 to 1. But 1 is 0 inclusive and 1 exclusive. Okay. So this is correct. Okay. Square bracket 0, comma, curve bracket, normal bracket of 1. Right. So I want to stop here because I think it's already time. Okay. So I will send this worksheet. There are 2 or 3 more problems, but I am going to give this as homework to you. Okay, based on the same concept. The concepts anything that you learned, did you find it useful, Prasanna?
Yes, sir.
Okay. Did you understand the concepts?
Yes, sir.
Okay. So there are 3 more problems. I think I wrote up to 10 problems. So I'm going to send this to you. Okay. So you try the remaining problems. 7 we already done. Okay. So there are 3 more problems. And please try that. Okay. And we'll meet in the next class. Okay.
Thank you, sir.
Okay, Prasanna. Take care. Yeah. Bye. You are in 11th class, right?
Yes, sir.
Okay. Fine. Okay, ma. Good night. Yeah. Bye.